This is the Visualization Concepts Learning Module. Upon completing this module, you should be able to identify the types of visualization interfaces used in industrial automation systems, list the primary features found in most human-machine interface solutions, and describe the benefits of scalable visualization solutions in automation. In general, the purpose of an automobile is to transport you from point A to point B. In order to successfully, safely, and consistently make that journey, we use many different interfaces, like a steering wheel, accelerator pedal, brake pedal, gear stick, or rear-view mirrors. Some interfaces, such as a dashboard, contain visual components like an odometer or speedometer. These interfaces are used by the driver to send commands to the engine and other systems, but also display feedback from those same systems. For example, the accelerator pedal is used to send the desired speed, and the speedometer provides feedback on the current speed and the rate of acceleration or deceleration. We see examples of interfaces every day. Stock tickers used to view up-to-the-second stock prices, an automated teller machine, or ATM, used to access account and view balances or history, microwave oven controls, or overhead digital signs used to display current traffic and weather conditions. On a plant floor, regardless of what customers might be manufacturing, processing, assembling, or packaging, they are taking a similar journey from point A to point B, turning raw materials into sellable products. During that journey, operators need to be able to access the state of the process, control and modify parameters, and visualize the direction of the process so they can intervene as early as possible when needed. Therefore, in order to reduce downtime and increase efficiency, it is imperative to understand how a change in a component may affect the overall process. That occurs with a constant exchange of data between the operators running and overseeing the process and the process equipment through operator interfaces. In the past, the exchange primarily happened through hardwired operator interfaces like push buttons, selector switches, gauges, and stack lights. Today, in addition to the hardwired controls, we are able to leverage networked electronic operator interface terminals as well as software installed and running on industrial-rated computers, as well as tablets and mobile phones. They are commonly referred to as human-machine interfaces, or HMI for short. The use of an HMI reduces field installation and maintenance costs by removing the wiring to each of the individual components. The typical control room today is more often characterized by a series of monitors rather than entire walls of buttons, lights, and switches more prevalent just a few decades ago. If we think of a control system as a system composed of input, logic, and output elements, visualization hardware and software plays a role in all three areas, as shown by these basic functions. Inputs start the line from keypad or touchscreen buttons. Logic makes decisions and enunciates alarms based on their severity. And outputs provide line status or show line speed. The HMI has evolved to become the central point for decision-making in manufacturing and industrial plants, whether for a standalone machine or across distributed systems. The demands put on the HMI only continue to grow as manufacturers seek to take advantage of new enabling technologies and differentiate themselves from the competition. Here are three of the main drivers. Companies want to access data that has long sat dormant in their controllers, machines, and processes, and they will rely on their HMI to contextualize and visualize this data for better decision-making. Manufacturers are increasingly adopting a flexible manufacturing approach to create more products and product varieties at a single site. An information-enabled HMI can help them better understand their processes to achieve faster changeovers, reduce downtime, and drive consistent quality. Emerging technologies such as mobility, virtualization, and cloud computing are helping manufacturers get critical information to employees faster and to more flexibly manage machines. They need a visualization solution that supports and embraces these new technologies. All of these devices provide the operator the means to visualize a process. Selecting the right solution depends on functionality, cost, location, certification required, amount of information required to view and control, as well as the existing infrastructure at the customer site. As we saw earlier, these interfaces can reside on the machine, in the control room, and or distributed throughout the process line. The most basic HMI devices transfer information in a single direction. That is, they send information to the system or they indicate status. Most status or output devices in this category are limited to displaying only alphanumeric information, such as alarm messages and part quantities. More sophisticated HMI devices offer both input and output data transfer. They typically contain additional visual tools and options which assist in both understanding and modifying the process. These much more flexible visualization solutions will be the focus of the remainder of this module. The more sophisticated bidirectional communication HMI solutions can be split into two categories: closed system and open system. A closed system is characterized by a device that is designed specifically to perform a single function. The traditional telephone is an excellent example of such a device. Even though users at either end of the telephone connection can both speak and listen, that is the only role of the original telephone. Upon power-up, these devices simply execute the HMI project that has been configured and downloaded to them. Dedicated HMI devices provide some unique advantages in manufacturing. They are tested to very specific global standards, industrial environments, and temperatures. For security, with specially constructed operating systems, these devices are also much less susceptible to viruses or malware. In fact, many units require no antivirus software to be installed at all. Dedicated devices are designed to run for extended periods of continuous runtime. Once a design has been implemented with enough capacity to withstand anticipated growth and application evolution, the expectation is that future investments in the same product will behave in the same manner. This is not necessarily true for commercially available computers with off-the-shelf operating systems. Lastly, they are easier to maintain and support. Network communications are either built-in or simple to add on and configure. Traditional PC-related maintenance tasks such as backing up and restoring a system state require no additional software. System upgrades are much easier to perform with the packaged solutions rather than miscellaneous service packs and individual patches. Additionally, mechanical moving parts, such as spinning hard drives, are replaced by more reliable solid-state storage mechanisms. In contrast to closed solutions, open systems provide multifunctional capability allowing for more creative uses. Today's smartphones are an excellent example of an open device capable of much more than simply connecting people verbally. These devices today are fully connected to the internet and social media. They store and play music, video, and games. Essentially, they have become an integral part of our daily lives. An open HMI solution in manufacturing contains a similar opportunity for flexible creativity and customization either on the plant floor or in a control room. Many of these systems are built on a standard Windows or similar commercially available operating system, allowing users to run an HMI project as well as many other compatible applications on the same PCs, tablets, or smartphones we use all the time. The newest, fastest, most advanced technologies are those developed on open platforms. Value-added solutions combine a controller and an HMI all on the same piece of hardware. On the technology curve, the latest operating systems, fastest components, and more memory make these solutions more suitable for either standalone or server-client architectures and improve data collection performance.